Let's suppose that entropy can be a function of different variables such as temperature, volume, and pressure. So ang gusto kong gawin is I want to develop a general equation that can be applied for any process and for any kind of gas, whether ideal gas or real gas. And to do that, I would like to start with the fact na si entropy can be a function nga of those variables. But I would like to do it just two at a time para hindi maging masyadong komplikado yung ating gagawin. So, let's say first na si entropy is a function of temperature and volume muna. Okay? Hindi ko muna i-include si pressure. Let's do it again later on. So, we will start with the expression na yung change in internal energy is equal to dq minus p external dv. And you're very familiar already with this equation. It came from yung ating first law mechanics, right? Galing siya dun sa fact na, di ba, yung du is equal to dq plus dw, right? Basically, ito yung first law expression natin eh. Right? But we have to remember na si dw is ito. Okay? Minus p external dv. Now, from this expression, we can simplify or rather arrange algebraically. No? So, I want to solve rather for dq. So, dq is just change in internal energy plus p external dv. So, inarrange ko lang yung equation natin. Now, what if I want q reversible instead of just q? So, dq reversible, okay, and I want reversible because we would like to calculate for the change in entropy. So, dq rev is equal to du rev, okay, ginagaya ko lang yung previous equation, plus pdv. Okay? Kasi for a reversible process, the pressure of the gas is equal to the external. Change in internal energy reversible, there is no such thing. Kasi kung gusto mong kunin yung reversible internal energy change, eh ganoon din naman, equal lang siya sa irreversible. Right? Because of the fact that internal energy is a state function. So, itutuloy ko lang yung pagsulat ng equation. So, dq rev, it's just du. So, let me just put here du kasi whether it's du rev or du rev, walang problema. Plus pdv. Now, ano ang susunod na mangyayari dito? Remember na si du, okay, or change in internal energy, we have an expression for that already, which we derive in our first law mechanics. So, i-insert ko lang or isa-substitute ko lang yung expression na yun dito sa equation natin ngayon. So, dq rev equals what? So, saan mag-i-equal si du? So, remember, du is cv dt, right? Du is equal to cv dt. Pero yung CVDT na yan, remember, pang perfect gas lang yan. So, merong second term kung natatandaan natin. So, yung second term niya is change in the internal energy with respect to volume at constant temperature dV. And this term, yung partial derivative of u with respect to that constant t, we have even a term for that. Yun yung tinatawag nating internal pressure. Right? So, yung du, okay, or change in internal energy, ito yung mga terms na to. Okay? Pero mayroon kang plus pdv pa. Okay? Coming from this one. Alright, now, what I will do next is I will divide by temperature or T. Yung buong equation na yan. And bakit ko siya ginagawa? Kasi, remember the definition of entropy. So, dq rev over temperature lang siya, right? So, kapag divide ko yung buong equation by temperature, magkakaroon ako ng dq rev divided by T. Yan yung entropy natin, or ds. Okay, so let me just go ahead and write ds. Equals, yung cv dt magiging cv dt over t. Okay? Plus, well, yung mga susunod na term, which are these ones, common yung differential v as a factor sa kanilang dalawa. So, let me just group these terms. So, ang mangyayari, kung i-divide natin pareho ng t, so let's just say 1 over t multiplied by those two terms. So, partial, let me use a bracket instead. Partial derivative of u with respect to v at constant t plus pressure. Okay, of course, don't forget to include differential v. So this equation now is the general entropy equation. Ibig sabihin, kahit ano pa man yung gas mo, perfect or not perfect, and kahit ano pa man yung process mo, isothermal, isobaric, etc., you can derive those equations galing siya dito sa general equation na to. So please take note of this equation. Halimbawa, mayroon kang isobaric process. So, pag sinabing isobaric, constant si temperature. Okay? Isobaric process. Now, let me replace that with an isochoric process instead. So, let's say isochoric process muna tayo. Or constant volume process. Okay? Constant volume. So kapag ganyan yung process natin, constant volume, ano kaya ang equation na mapapala natin coming from this general equation that we have obtained? So ang gagawin ko, let me just rewrite that general equation. There you go. Since isochoric yung process natin, dV or change in volume is 0. So mawawala na agad yung buong term na ito na mayroong dV. Okay? So what will happen then? Ang mangyayari, ang maiiwan na lang sa equation natin will be ds equals cv over t dt. Therefore, to get delta s, all you have to do is integrate that. Integral of cv over t dt. Okay, dt from initial to final. In other words, ang pinakita ko dito is that kapag meron kang constant volume process, whether perfect gas pa yan or hindi, okay, that general equation na na-derive natin dito ay na-reduce pa rin sa isang mas simpleng equation. Okay, ibig sabihin, you don't have to really memorize this equation. Ang gawin nyo lang is take note of this equation above, which is more complex, mas general siya, pero gamitin nyo yan para makakuha ng iba pang klase ng equations specific to whatever process ang kailangan. Let's say, ang isunod naman natin is an isothermal process. Okay? And alam natin na kapag isothermal, constant si temperature. Tapos, another condition that I'd like to include here is, let's say meron tayong perfect gas. Okay? So, ano kaya ang mangyayari sa ating general equation right here? How do we reduce this for the following conditions na isothermal and we have the case for perfect gas? So, let me rewrite that equation again. Ayan siya. Now, since isothermal po ang ating process, mayroong mawawalang term which is the first term of that equation kasi mayroong kang dt dito. Isothermal tayo, therefore there will be no change in temperature. Now, sabi natin dito kasi perfect gas. So pag perfect gas, naalala ninyo na this term right here will also be 0 for an ideal gas, right? Ibig sabihin, ang mangyayari sa general equation natin is that magiging ds equals p over t na lang dv. Okay? Now, how do you exactly integrate this equation? Meron kang differential volume, so you need to find an expression that contains the variable na volume. So, saan pa natin kukunin yun? Di sa ideal gas equation, kasi may perfect gas naman tayo, di ba? So, PV equals nRT, but the volume, or the pressure is equal to nRT over V. Para yung pressure expression na yan, isa-substitute natin dito. So, let's do that. Yung ds magiging nRT over V. Tapos may temperature ka ba doon, tapos dV. So, it will become ds equals, mayroong ibang variable na makakancel, which is temperature. Right? So, nRV na lang ang matitira. So, N R divided by V dV. Now, you have an expression which contains the variable volume and it can now be integrated. So, if we integrate this, okay, integrate ds, that will become delta S, and let's also integrate this from 1 to 2. So, magiging delta S, ano bang integral niyan? NR is constant, but 1 over V dV, ang integral niyan is ln of V2 over V1. So, yan na yung gagamitin mo ngayon na equation kapag perfect gas tsaka isothermal yung process. So, kung ako sa inyo, take note nyo na lang yung, again, yung ating general equation. Okay. So, yung ginawa natin ngayon is we assume that entropy is a function of temperature and volume, right? Now, what if ang isusunod natin is yung entropy ay function naman ni temperature din, pero this time with pressure. So, what will happen? Kapag ganyan yung ating function, maybe we can start with enthalpy. So, remember the expression for enthalpy, diba? dH equals dQ plus VdP. If you want to recall paano nangyari yan, well, balikan nyo na lang yung definition ng enthalpy, which is U plus PV, right? And do the differentiation to get at this point. But anyway, let's just start with that. And if I would like to rather look for reversible change in enthalpy, so magiging dQ rev tayo plus VdP, right? However, gaya ng ginawa natin kanina kay internal energy, yung change in enthalpy reversible, parehas lang yan sa enthalpy irreversible. Kasi the same with internal energy, enthalpy is also a state function. So, what will happen? What will become of our equation? So, magiging dH na lang siya equals dQ rev plus VdP. Now, ano ba yung definition or equation for dH? Kung matatandaan natin, yung dH is Cp dt, right? Cp dt. For an ideal gas. Pero kapag hindi ideal gas yung meron tayo, tatandaan natin na meron pa siyang second term. Delta H with respect to P at constant T. Right? So, ito yung ating change in enthalpy expression. So, meron pa tayong dP dito. Okay. Equals. So, nandyan pa rin si dQ plus VdP. Now, the same with what we did earlier, divide natin sa temperature yung buong equation na yan. So, what will happen? Magiging Cp over T dt. Yung second term naman ng left hand side, ano mangyayari? Let's just say 1 over T kasi divide natin ng T. And then just write that expression, partial of each with respect to P at constant T dP. Alright? Equals, yung dq rev, pag dinivide natin to ng temperature, change in entropy na siya. Plus, yung VDP divided natin sa temperature, V over T, dP na siya. Okay, let's do some rearrangement a little bit. So, kung gusto kong i-solve si DS or change in entropy, rearranging the equation magiging Cp over T dt plus 1 over T. I'm just combining terms here and meron kasi silang common factors. And there you go. This is now the general expression that we obtained for change in entropy. And similar to what we obtained kanina doon sa naunang derivation natin, this equation is also special because from this general equation, you can derive some other equations suitable kung anong klaseng process at kung anong klaseng gas or system meron ka. So for example, meron tayong isothermal process. So, isothermal. And meron tayong perfect gas halimbawa. So, what will become of this general equation? So, let me rewrite this equation. Ayan na siya. May konting kulang. There should be a bracket here. There you go. Now, since isothermal yung process natin, edi walang change in temperature. So, automatic, mawawala na agad tong first term natin. Right? And since we said here na ideal gas or perfect gas, this term will be 0. So, tatandaan nyo lang yan na yung term na yan, pati yung partial of u kanina na term, 0 yan kapag ideal gas. So, yun yung mga thermodynamic definition of perfect gases. So ano na lang maiiwan sa temperature natin? Yung change in entropy natin will now become negative V over T dP. Now, let's find an expression for volume that contains the variable pressure. So syempre, mangagali yan kay perfect gas equation. So yung volume, according to the ideal gas equation, it's nRT over P. Substitute natin yan. So, ds, or change in entropy, equals negative nRT, okay, over P times T, dP. Cancel ko lang saglit yung temperature, okay, para ang maiwan ay change in entropy is equal to minus nR over P dP. Tuloy natin. So, ano mangyayari dito? Integrate natin from condition 1 to 2. So, integral of ds as delta s equals integral nitong term na to, yung right hand side ng equation, minus nr is constant, and then integral ni 1 over p dp is ln p2 over p1. So, yan ngayon yung ating equation kapag perfect gas and isothermal yung process. Okay? Paano kapag isobaric? So kapag isobaric, wala tayong problema. Kasi whether it's a perfect gas or not, from this equation kasi, kapag isobaric siya, di ba constant pressure ang ibig sabihin nun? So, ano makakancel? Buong term na to cancel. 0 yan. Okay? So, wala tayong pakialam kung ideal gas man o hindi. So, ang maiiwan sa ating equation, therefore, is ds equals Cp over T dt. So, to get the delta S or change in entropy, integrate mo lang yan. So, yun lang, no? Integral of Cp over t dt from initial to final conditions. So that will be your equation for the given condition. Again, let me emphasize and reiterate, all you have to do is sort of memorize this general equation, that and yung isa kanina, which is ayun. So kapag alam mo yung dalawang equation na yan, just do the cancellation and reduction of those equations to suit kung ano man yung process at condition na meron ka, and you will be able to arrive at all these equations. So, hindi mo na kailangang i-memorize yung mga equation na iyan.